Okay, we're going to go through rotations now. So a rotation is just another transformation. It's the third one we've talked about. The previous two were reflections, and then we did translations. A rotation, we've called it a couple different things, but the smallest definition that I can give you is turning something. But a rotation is a transformation that moves all points of the preimage through a specified angle and direction about a fixed point. Okay, so when we say angle, when I rotate something, it doesn't have, it depends how far you rotate it. It could just be a quarter turn, which would be 90 degrees. Also, you got to do direction. Is it clockwise or counterclockwise? And then about a fixed point just means that there's going to be a point there that basically, like if this is where that point starts and I rotate it like that, oops, didn't mean to make that a straight line. If I rotate it over here, they stay the same distance away. Like all of this would be the same distance as it rotates. The best way I can think about that is if I put a little chalk on my tire, maybe consider this here as a tire. If that was a wheel on your car and you put a little point on it, as you're driving the car, it would just go along the edge, right? All the way to the top again, and it would stay the same distance away on all of those parts of the tire. Okay, so clockwise versus counterclockwise. That's something that we have to talk about. When we talk about clockwise, the second hand goes around the clock. All of the hands go around the clock going that way. So you have to kind of think about that as we go. Basically, for all of the problems that I give you, I'm going to tell you whether it's clockwise or counterclockwise. If we don't tell you what it is, if it's counterclockwise or clockwise, if we don't tell you, you have to assume that it's counterclockwise. Never assume that it's clockwise. Always assume counterclockwise. But we're going to tell you most of the time. Given A equals 5, 2. So 1, 2, 3, 4, 5. 1, 2. Oops, I don't have my pen up. 5, 2. Okay, I'll label that as 5, comma, 2. It says we want to rotate it 90 degrees counterclockwise about the origin, meaning just around the origin. The origin is basically our fixed point. So if that's true, if we're doing that, the best way I can kind of show you what we're doing here is so I'm going to have to turn my iPad, and I want you guys to turn your Chromebook as well. And picture, if you have it normal, my x-axis is obviously right here, and my y-axis is right there. But if I turn it, I want you to pretend that this is your x-axis and this is your y-axis. Okay, so turn your Chromebook now, pretending that this one is your x and this one is your y. If you do that and then count out 5, 2, 1, 2, 3, 4, 5, 1, 2, the point's right there. This would be like your point. Now you got to turn your Chromebook or whatever you're using back over. Maybe you just tilted your head. But that point right there, what is that actual point? That point is actually -2, 5. Okay? 180 degrees. Now you got to turn it upside down and count it out with me. So this one would be like your x-axis, but it'd be the other way. So we'd be going 1, 2, 3, 4, 5. 1, 2 would be right there. And then if you turn it back over, this point is actually -5, 2. And then we turn it one more time. 1, 2, 3, 4, 5. 1, 2. There'd be a point there. And it would be 2, -5. Oh, I forgot. This is a -2 as well. Okay. So that we just did. We just rotated them. Well, that was the 270 degree rotation. 270 degrees is 3/4 of the way around, by the way. Some people don't know that. But anyway, now we're coming up with some rules for these, and I already have them written out because sometimes they're a little tricky, so I did it beforehand. These are not something, well, they are something that you're going to probably memorize because you do so many things with them, but this is something that probably should be memorized, but it's not really that tough to memorize. If I think about it, well, maybe I should explain it first. The 90-degree counterclockwise rotation took us from this point to this point. Well, what happened with those points? Not only did the y and x switch spots, like I have down here, they switched spots, but also the y value, which was that 2, became a -2. So that's why I have the negative, or the opposite as I call it, in front of the y. If we went 180, we're going from this one to this one. The x and the y actually stay in the right spot, right? The only thing that's different is that negative out front on both of those. So it's the same exact thing. 5, 2 turns into -5, -2. It's the same thing, except, let me get those erased. We have negatives, okay? And then the last one here, 5, 2 turns into 2, -5. So again, they're switching spots. And this time, the x is turning into a negative number, which is why we have the negative, or the opposite, there. Okay, and then the last one's pretty simple. A 360-degree rotation brings you back here. So you start here, you end there, and it doesn't change. Okay, so those probably need to be looked at until they're memorized, or at least until you understand them, because we will use them quite a bit. So it wants a 90-degree counterclockwise rotation. This is where things get a little bit tricky. So there's only one way that I can ensure the success of all of you. I would say it's in your best interest to draw out all of the points of this triangle, to actually write them out. I know it's a lot of work, but I think it's the best way, especially if you're doing a test, to get the right answer and to be sure you get the right answer. So if I labeled these A, B, and C, then point A, I might zoom in for this. Point A would be at 3, -2. Point B would be at 5, -4. And point C would be at 1, -5. Okay? Those are changing. We're changing them. So I'm going to put parentheses around them. I'm basically writing rules here. They're changing. How are they changing? In 90 degrees counterclockwise rotation, what did we say was our rule for that? That was this guy, right? We're switching our y and our x, and we're making the y a negative. Or I guess we're doing the opposite. So this one, the y was already negative. So if we're switching our y and our x, the -2 comes in front, but the y value changes to the opposite. So it'll look like that. Letter B. The 4 is going to the front, and it's changing to a positive. 5 stays the same. 5, 1. Okay? There's a pattern there. You have to maybe pause the video and figure it out if you didn't get that. But these are like my A prime, B prime, and C prime. Okay, so if I fill these in, A prime was at 2, 3. That's right there. I can even label it A prime. B prime was at 4, 5, which is up here, B prime. C prime is at 5, 1, C prime is right there. See if I can make this triangle. Boom. That's rotated. 90 degrees counterclockwise. Again, make sure you're going counterclockwise with it. It should be going this way. That's counterclockwise. Let's do the next one. 180 degree rotation. Again, let's label them A, B, C. Where is A located? A is at 2, 1. B is at 4, negative 5. C is at 5, negative 3. It's changing too. Okay, what's our rule for 180 degree rotation? Our rule was the x and the y stay in the same place, except they both become negative. So that'll be really easy. Or I guess I shouldn't say that, I'm sorry. I shouldn't say they both become negative, because if they're already negative, then they're going to become positive. So this one would be negative 2, negative 1. This one would be negative 4, positive 5, right? Because it's the opposite. And this one would be negative 5, positive 3. Let's put those on here. So negative 2, negative 1. Negative 2, negative 1 would be there. That's A prime. Negative 4, positive 5. 1, 2, 3, 4, 5 would be right there. That's like our B prime. C prime was negative 5, positive 3, which is right there. C prime. Do my best to draw it. Oops. Just like that. That's a 180 degree turn. Counterclockwise. I guess counterclockwise and clockwise is the same. If it's 180 degrees, it end up in the same spot. So, all right, segment. So now it's just a segment. That doesn't change anything. We just have 2 points this time. And we're going clockwise also. Okay, so we got a couple new things here. We're going clockwise this time. So let's just draw these out first. So there's A prime, B prime. So I'm sorry, they're not primes. Let's switch that up. So that's just A and B. Those are our original images. So A is at negative 2, 1. B is at negative 4, 5. We're changing. And we're going clockwise this time. Well, if you think about a clock, right? 90 degree clockwise rotation. Let's just say I'm starting right here. A 90 degrees clockwise rotation means it would end up down here. We'd call that 90 degrees. Well, if we're going counterclockwise, how many degrees is that going backwards this way? That's 3/4 turn, which would end up being 270 degrees, or that guy right there. So y comma negative x is what we're looking at here. We're switching our x and our y around, and then we're making the x a negative or opposite. So again, switching them around, and then making our, which one was it? Our x goes to the back and becomes the opposite. Well, on this one, our x was negative, so it's just going to stay positive then. On this one, the 4 is going to the back and becoming positive. The 5 is going to the front, and it's not changing. So then 1, 2 would be there for A. And B would be at 5, 4. 1, 2, 3, 4 right there. And those are primes. Okay, moving on. A circular dial has 8 equally spaced points as shown. Point A is at the top of the dial. Suppose that the dial is turned clockwise until point F is on top. How many degrees did the dial have to turn? So if I turn this whole circle, if I turn it and then F ends up at top right here, how many degrees did it turn? The way that I would figure this out is I got to figure out, first of all, if it was just one turn, if A moved to the spot where B was. So it would end up looking like, this is a bad drawing, but let me actually fix it. I can actually draw a perfect circle here. Let me try again. Okay, there's my perfect circle. If A ended up there, B, C. Well, anyway, that's where A would have to be. I can't probably space them out perfectly, but A would be right where B is right there. To figure that out, I can cut it in half. I know that's 180, right? Okay, now we're at 90 degrees. Cut that again. Cut that again. How many degrees is this angle? Well, it's 360 divided by however many slices we have here. Looks like we have 8 slices. So 360 divided by 8, that's 45 if I'm not mistaken. So each of these is 45 degrees. And how many degrees, how many slices are we moving in here? Well, we're moving it 1, 2, 3 slices. How many degrees is that? We just multiply that by that 45. And we would get, so 12, 135, I believe, 135. All right, quickly with this last question here. Let's figure out where it's ended up. X prime is at 1, 2, so it's at 3, and then 1, 2, 3, 4, 5. So -3, -5 is where I caught that one ending up. Next one. And basically, I don't even have to look at the image anymore. I could do this with my hand over the picture because I just have to do the same thing that I did on the first one. It looked like X and Y switch spots. And those are both 1, so they don't matter. And then which one stayed the same? This one did. The back one did. The 5 stayed the same. It was still negative, so I'll keep that one the same. And the other one changed to opposite. Okay, so maybe that didn't make sense. We could just check out where Y was, because that's not right. So let's just figure out where Y is, which is right. Oh, so Y prime would be right there. Oh no, that was right. So they're both -1, -1. Okay, sorry. Z prime is right here. Looks like it's at 4, -8. So right there. Let's figure out what's happening. We only have 2 options really, because those are switching spots. So it's either going to be this one, or maybe I shouldn't use an X. It's either going to be this one, or it's going to be this one. Now, which one is changing? Is the X changing, or is the Y changing? If the Y is changing, it's 90 degrees. If the X is changing, it's 270. Looks like the one that's changing is the Y value because it went from 3 to -3. So we said that was a 90-degree rotation. Which means if the Y is changing, sorry, froze up on me. If the Y is changing, then it would be this one because they switched spots and the Y changed. Okay,